So in this lesson we're going to have a look at an angle fact that affects the angles inside a triangle. So if you look at these two triangles here, they're totally different. The one on the left is an obtuse angled triangle. One of the angles is bigger than 90. Right, your one on the right, all the angles are all less than 90 degrees, so they're all acute. It's an acute angled triangle, but it actually wouldn't matter what type of triangle we had drawn. What I'm going to show you is that if you put together the angles from the corners in the following way, so if you put the pointed part of each of these angles, imagine you could tear it off. What I'd like you to notice is that when we fit them together in this way, you can hopefully see that what we end up with in each case is a straight angle. So my diagram here is probably a wee bit tricky to manoeuvre, but if you were doing this practically, you could tear off the corners. You could show that all of the angles, no matter what size they are, they will fit together to make a straight angle in this way. And this other triangle, do the same thing here. So leave that one as is, bring that one across, right, bring this one down, turn it round so that the pointy bits are all together. And what you'll find is that in fact, right, for any triangle, all three angles fit together to make your straight line. So what that tells us, because we know the angles that fit together on a straight line, supplementary angles is the term you met in the last lesson, but they always add up to 180 degrees. So because we know that angle fact about a triangle, any triangle in fact, we can use that to work out if we know two angles inside a triangle, for example, we'll be able to work out what the third angle is. So here we would need to say that 28 plus your 113 plus the y, all three of them add together to make 180. So that means if I add up my 113 and my 28, I will get 141 degrees. So to work out the missing part, I need to do 180, take away the 141 that we've got there. So we would end up with your missing angle y would need to therefore be equal to 39 degrees, and that's without doing any measuring with a protractor. That's an angle calculation. That is using this fact here that we know all three need to add together to make 180 degrees. Now let's look at some further questions that have got triangles in them, but also got some additional angle information as well. So if in this diagram here we just looked at the triangle, at the moment we've only got one angle inside that triangle. So if you've only got one angle in this way, we can't work out what x and y are. We can't assume that they're equal. We're not told that they are equal in any way, and in fact if they were equal it would be the same letter that would be positioned in there. So that means there must be some other information that will allow us to work out these, and actually it's this part here. If we just focus in on this bit of the diagram for the moment, ignore the y and the 54, just look at here, we can see we've got a straight angle going on here, which means that our x and our 98 they are fitting together to make a straight angle. So that means they need to add up to 180 degrees. So if I do 180 and I take away the 98 from there, I will be able to work out that I've got 82 degrees left, which means that's the size for angle X. So there's the first one worked out. Once you've worked out what angle X is, so we now can put that into our diagram, we can then see in that triangle that we've got angle Y plus the 54 plus the 82 that we've just worked out, and all together they come to 180 degrees. Notice the 98 is not part of inside the triangle, right? So we don't include that here, but what I do need to do is add up my 82 and my 54, and I'll get 136, and then I need to do 180, take away that 136, and of course I'm doing that, I'm going to get 44, and that's what size angle Y is equal to, so 44 degrees. So we were actually using two different angle facts there. You're using your angle fact for straight angle to work out the first one, and then you use the angles in a triangle. So this bit here was the triangle working, right? The other one, this one here, was to do with looking at the straight angle. So make sure you are aware of when you're using what information. Here's a third question rather. Right, again, we do have a triangle going on in the diagram, but we've got quite a few missing angles that we're going to fill in. Now down at this corner here, we can clearly see that we've got two straight lines crossing over each other. When that happens, you get vertically opposite angles, so that would immediately mean I could fill in the one straight across from that, and that would be 70 degrees. Now what I've got inside that triangle, I've now got a 52 and I've got a 70 if I add them together. This is me looking at the triangle now. So in the first instance we use vertical opposite angles. Now I'm working on the triangle, I'm doing 52, add 70, so I'm going to have 122 degrees here, which means to work out the angle up at the top I need to do 180, take away the 122, so I'll be looking for an angle of 58 would be the one going in up at the top. Now of course that's not all the angles in the diagram. You can clearly see there's another couple of angles going on here. So to work out this one down in here, we need to see that as being a straight angle on the top there. You ignore the bottom bit of it, and you know that your 70 plus this angle here would need to be equal to 180. So if you do 180 take away 70, you'll get 110. So that's what size that one is, and then of course the one straight across from that is 110. So you can actually fill in quite a lot of or all the angles in that diagram. So be aware that you can be using previous angle knowledge for working out, so looking for straight angles, looking for vertically opposite angles. Now you also know about the sum of angles inside triangles as well.